Good morning, everybody. Welcome to Building an ORM from Scratch. I'm really excited about today's lecture because it's going to take the SQL concepts that we learned yesterday, and we're going to apply them to Ruby. So the gap between the Ruby and SQL gap is starting to close. I know it feels like a jump just going straight from Ruby to SQL, but we're going to kind of take what we've learned ahead and retrace it back and connect it to the knowledge that we have with Ruby. Before we get started, were there any questions or anything that I went over yesterday that we wanted to kind of clarify or go over? Okay, I'll start sharing my screen, and a couple things that I want to go over today. So like, here are some goals that we have. I want to build an application from scratch. So you can kind of see that, I know when you download an application from Learn and you're working on someone else's code, it's hard to determine what are the essentials here. And what is part of the Ruby gem, what is part of the legal stuff. So I'm just going to try to build something from scratch, just so you can see like what is really necessary to get started. Today I also want to practice visualization of databases. If we haven't done so yet, I just want to do a little quick exercise. And Jen, if you wouldn't mind helping me out with doing like, maybe this can be kind of a group thing, and we can have like a small breakout room situation later where students can work with each other. But I just want to practice visualization of databases. Can you imagine what a domain model looks like? And then some key takeaways or things that I want people to feel like they can do or are aware of is that we can use Ruby Ruby and SQL to determine the database structure. So once we've decided what we want our domain model to look like, we can write Ruby code, Ruby with SQL code to execute and create the database the way that we see fit in our image, to determine, and I guess also update, but I don't think we'll be doing much updating today. I think it's just kind of good we'll make our focus to make sure we're doing it right the first time, but you'll get good at altering your databases and you need it. A topic that we touched on yesterday that I want to iterate over again, wow, love a good Ruby pun, is the most important element of the most important element of a Ruby instance, or I would say the most important attribute of a Ruby instance is now the unique ID, not necessarily the, I don't know what exactly I would call that, the specific word, but the memory code. And then I think the most noticeable difference is that you'll be able to see the difference in how we notice the difference in how we set up classes, or set up our model files now that we're using SQL. Okay, any questions about any of this stuff? Looks like I have something in the chat. Let me see, hold on. Location? Jesse, what do you mean?
I think he was talking about like when you're referring to memory saving or whatever.
Not necessarily the memory code. Yeah, that points to the location in your memory. So making this jump from, we're using Ruby instances that are stored in our computer temporarily, right? Just for the course of our application session or our PRI session, right? And as soon as our application ends or our IRB session ends, those Ruby instances in memory go away. Now we're working with more permanent memory, right? Memory that's designed to contain and persist this information. So the domain model that we're going to build is we're going to create kind of like a Twitter application. So like mini Twitter, domain model, mini Twitter. And we're going to have two classes. We're going to have a user class, and we're going to have a tweets class. And our tweet class, and I think today we're just going to build out the user class together, and then tomorrow I believe we're going to do a pairing where we'll kind of do like what we did in the first week, where we'll kind of have some deliverables, and everyone who's in the study group will go into breakout rooms, and Jen and I will be hopping around and helping students build out the second class so that you'll have practice creating two classes, two tables, and really working with the concept of the relational database. So really quickly, I just want to open up this. Oh, we got another question. The primary key. Yeah, we'll talk about primary keys and stuff in just a sec. So I was just doing this exercise with another student, and I think it would be great to do now. I just want to whiteboard really quick, and let's talk about what these tables are going to look like, right? If we were to kind of use our DB browser to visualize what our database would look like, let's just draw it out now. So I have my user class, and I have a tweet class. And what are the attributes, what are the columns that are going to go in the database for a user, for instance? So feel free to just shout out or put it in the chat. What are the, okay. So we do have a name, and that could be the only thing that we need. Thank you. That's what I was looking for. Lucy mentioned that we now have an ID. The ID is the primary key, right? We have the name, and then sure, we can also have it like an email. So let's just do this. And then I'm going to draw out the table. Okay, cool. And so I have my users table, right? Remember the model is always singular and the table name is always plural. And my rows, or the columns that I'm going to have, are going to be ID, name, and email. And then we can say 1, Jen at Flatiron School, right? 2, Chris. So great, this is what our table is going to look like. When this illustration is done, can we leave it up for review? Yeah. And totally, I can screenshot it, and this is also being recorded as well. Okay, so now let's work on the tweet. What column names is the tweet going to have? So also an ID and a message. And then maybe we can do a fun one like the day, right? Or like a date time. This might be kind of tricky to do. But we can just say like, we can do date, and then when you guys build it up, we can leave it up to kind of your interpretation. But again, we also have the primary key here, and if we're doing this correctly, we would also want to list out the data types that we have. So the name is also going to be text, and the email is also going to be text. Message is going to be text, and the date time I think is going to be numeric. All right. And then again, oh, we're forgetting one thing. We're not done. The tweet is missing something. Exactly. It's missing user ID, is an integer. Perfect. So now we got this going on. Something kind of like this. Got our tweets. The tweets have an ID, primary key. They have a message. They have a date. And then over here they have a user ID, right? So if I were to write a message, this is the first tweet ever. First tweet ever. It was done December 11th. And the user ID is going to be what? If Chris, if I wrote the tweet. It's going to be exactly. So remember, the primary key is the key that uniquely specifies which row this is on its particular table. And the foreign key is saying, if you want a little bit more information about this, you're going to have to go look at a different table, right? Remember that, can someone explain to me what kind of relationship this is? What kind of relationship is this? Right. Brandon, can the primary key ever overflow? Can you explain that a little bit more? And Ethelbert is exactly correct. It's exactly correct. It's a has many belongs to relationship. I don't know why I wrote it like that, but remember, in a has many belongs to relationship, the element, the model or the class that has many never keeps track of what it has many of. The model that belongs to another class always keeps track of whom or to what it belongs to by maintaining that foreign key. So if I'm a user Chris and I want to go look at all the tweets that I wrote, I go look at the tweets model and I check for every tweet row whose user ID foreign key matches my primary key, right? We know that I wrote this tweet because the foreign key on the tweet class or on the tweet row matches my primary key on the users row, right? Very, very important to remember. And this is kind of why, you know, at one point in the curriculum, we had it set up such that a user kept track of its tweets in a tweets array, right? But then we switched towards this other idea, or the second concept, where if a user wants to go see its tweets, right, we have to iterate over each tweet in the tweet class and select all of the tweets where the user instance matches the user object of the user instance itself. That's a little confusing, right? So if I wanted to see, if I were Chris, if I had an instance of Chris and I wanted to see my tweets, we would iterate over all of the tweets and say, which of these tweets has a user whose user instance matches Chris's user instance, right? We'll look into this a little bit more. But again, important concepts to remember here are single source of truth. This is really kind of what's happening here. Maintaining single source of truth, and relational integrity. Right. If we delete Chris's account, Chris's tweets should disappear as well. Single source of truth, relational integrity. Any questions about this before we move on? And I won't erase this, and we can bring this back in the future as we need to kind of reference this. Don't be afraid to ask questions in the chat at any point, even if we've moved past what you're having a question on, even if you're still formulating your question, it's never too late. We're happy to answer. Okay. So going back to our empty our empty repository here, like I said, I'm going to start this application from scratch. So the first thing that I'm going to create is the gem file. And in my gem file, I just need SQLite 3 and handy dandy pry. I think that's all I need so far. I'm going to start making just files, and then at the end, before we go, I'm going to separate them into folders just for organizational purposes, but I just kind of want to demonstrate again for this simple of an application. We don't need too much. So I'm going to have, we're going to start off again just making the users today. And then tomorrow during the pairing, where Jen and I will be watching you all, we'll be guiding you through creating the tweets. So today I'll just have a user.rb file. And I'll have an environment file. Remember that we need to create a database, a file that's going to be used as our database. So usually the database is named the same name as the app that you're building out. So I'm going to say tweets, users, ORM.db. It's going to be my database file. And then I'm going to have a console.rb file where we'll just have that binding pry and where we'll run it. Cool. So I think this is all we need for now. In my environment file, I just need to require SQLite 3. And I want to require pry. And then just like we did yesterday, I want to create a DB, and I'm using capitals here because I want this to be globally accessible, right? I want my other applications to be able to access this DB. And I'm going to use the SQLite 3 gem and go inside of the module database and create a new instance of a database, right? And I'm going to pass in as an argument the directory of where I want the database to be set up, tweets.users.orm. or tweets users orm.db. As a side note, I think that I may have forgotten to explain what an ORM is. An ORM is basically what we're going to be building out, right? Let me put this in here. Build an ORM from scratch is what I mean. ORM/application from scratch. Let's see. Yeah, so an ORM is an object relational mapper. And it basically is an interface that takes information from a database and animates information into manipulatable objects, right? Manipulatable, is this a word? Manipulatable objects, right? Inside of a database, the rows are just rows of information, right? But you have already experienced the magic behind object instances, right? Being able to call methods on them, being able to relate them to each other, right? We want to be able to take the rows from databases and turn them into Ruby objects and then allow them to behave as if they were, behave as Ruby objects, be dynamic, be able to change, right? Taking the dead or just the very simple information that's in a database and yeah, I think I'm just repeating myself over and over again. But bringing them to life, allowing them to be dynamic and for us to play with them, for us to feel like we can do things with them, right? Okay, once it's a Ruby object, we can call methods on it, we can map over it, we can create arrays, relate them to each other, right? This is really kind of what we're looking for. This is what object relational mappers do. We're building our own from scratch, but at the beginning of next week, we're going to introduce you to Active Record, which is going to be your ORM moving forward. And it's super powerful, super handy, and you're going to love it. Okay. This is going to be our database. And one thing that's going to really help us out, remember the DB here is an instance of a database, and the argument that we're passing in is the directory for where this database can be found, right? We're telling this database instance, take this file that I created, there's nothing in it, and do what you need to do to make it behave like a database. And then this database instance has a few attributes that we can change, right? We can also call functions on it. But results as hash is basically like an instance variable, right? That I'm imagining is default set to false. But we're going to set this to true so that the results that we get from the database whenever we make queries are hashes. And I think, again, this is going to help us out a lot in the future. So let's just leave this here for now. And then we will come back and edit this file as necessary. I know that I'm going to need to require it here. Are there any questions so far? Got my gem file, got my environment
Yeah,
file.
that method you called on the DB instance, is that the same methods like inside SQLite 3? Like when you come up with the menu options or whatever, the .help?
Yeah, exactly. It's like these are just instance methods that have been defined. One thing that I did with a student that I was just on a call with is that we can actually go look at SQLite 3. We can go look at the source code, right? Most gems that you interact with, the entire source code is on GitHub. And even if you don't 100% understand what is being said, it's kind of helpful to go check it out, right? These are gems just like for those of you who built out your projects in the gem-like fashion. These are created the same way, right? So if we go inside of the lib folder, we can see database. Oh, this is the database that, the class database that we are, that we're using right now. And we can see that in the class database, there's an attribute accessor for a variable, an instance variable called results as hash, right? And we can change that. We see that in the initialize, the argument is a file with, some extra arguments that have default values that we didn't use, right? So if you're ever curious about how these functions are working behind the scenes, just Google it, see if there's a GitHub repository, and just go take a look at the source code. I think that that's always really helpful to get an idea of what was this person thinking when they were building this gem. Let's see, awesome. Okay, so now, so again, we have our console. It's just gonna run a pry session. We can later, we'll put some sample code here to make sure everything is working. And then we can use our pry session to, again, play around and test with what we have. Our environment file, we're gonna build out as we go. So far we have everything we need, just the SQLite and pry. And then I have my gem file, the readmes where we're keeping track of everything we're learning. The tweets.users ORM is, as we continue, we'll see those weird characters here as Ruby, the SQLite gem, turns this into a database. And here's where we're gonna get started. We're gonna build out our user class. So we have our class user, and I don't know. Let's have, what do people think we should build out first? What are we used to building out first? Okay, we should have an initialize method. I think that's great. And then we should have our attributes. So let's, yeah, I like having an attribute accessor. And then let's pull up the whiteboard again. And let's see what we have for a user. We just have a name, an ID, a name, and an email. Awesome. Okay. I wish there was an easier way to, I think there might be an easier way to transfer. So ID, name. So this is really interesting. We're going to really play around and pay attention to how we use the attribute accessor, or how we just use an ID. in this case, because we don't, only things that have been successfully stored in the database should have an ID, right? We don't want to put the primary key integer. We want the database to be responsible for deciding that, for assigning that, right? So we have to be careful. We don't want to put an ID if there isn't one. And again, we'll pay close attention to this. Cool. ID, name, and email. And then, we'll get to that in a second. Okay, so we actually, Nathalbert wrote to me that we should have an attribute reader as an ID, but this is not necessarily what we want to do, because we want to be able to use the same instance and be able to assign it an ID later. For our initialize method, for those of you who haven't used send yet, I think that this is kind of that the send method is kind of the best way to initialize instances that we're pulling from a database. So we're going to imagine that the information that we're going to get from the initialize method is going to be an attribute hash, right? So if we're creating a new instance of a user, that should be ID is, nil maybe, or, and this is the beauty of the send method that we'll go over again if you're not familiar with it, but it only applies to what is passed in. So if we're creating a new user, and this is a user that we're creating ourselves and we're not passing to the database, or we're not getting from the database, we're probably going to expect that it only has a name and an email. Okay. So how the send method works is the first argument of the send method is an interpolation. Oops, I have to actually we have to iterate over this hash, and we have the attribute and the value, right? And we essentially take the attribute. We have to do that's. Oh my goodness, I'm forgetting. I think it's self.send. Self.send. So remember that initialize is run after an instance has been created, right? So the self in this method refers to the newly created instance. Send is a method that receives two arguments. The first argument is the name of the method that we want to call. And in this case, we want to be calling our attribute accessor or our writer methods that match the name of the attributes that we're trying to assign. So we interpolate here because we're iterating over, and these are going to be variables, right? And in order to make this a setter method, we have to put an equal sign afterwards, right? And then we're going to be putting the value. So that's the second argument. So for example, if we were to kind of just do this for name, we would be saying like self.send, and then this would be name equals, and then we would be putting Chris, right? This is how send would work for just one attribute, right? But because we're receiving a hash, and we don't know if this hash has 2 or 3 key value pairs, we're using our iterator each, and then we're interpolating. Does anyone have questions about how send works? And I guess it's also helpful to point out that what send does is it says, okay, well, I'm going to take this first argument here, and I'm going to guess, or not guess, but I'm being told that there is a setter method called name, and that I should ultimately pass it the argument, Chris.
Chris, the stuff coming into the attributes hash, will the keys be symbols or strings?
That's a good question, but I think, ooh,
Because I know it works as a reader method if they're symbols, but because we try to add the equals, I don't know if we have to convert it to a string first.
When I practiced this earlier, I did it.
It worked? Cool.
Yeah. But this is a good point. And let's play around with this later when we start making instances, which I guess we can kind of do now. So I'll go in here and let me go into, let me go into my tweets ORM. And I'll bundle install. And then let's open up the console. Oh, and I have to do one thing in my environment file. I need to now require my user.rb file. And we will get into why the order of how we're requiring things matters in this case. Let's see if this works. Okay, so we have a user.new. And now I'm going to say the name is Chris. And the email is chris@flatironschool.com. Okay. So far, so good. Notice that I don't have an ID. So maybe what we can do here. I think we can do. I think this will work. So what I'm basically going to do is use this or equals operator to say if the attribute hash that was passed in included an array, or sorry, included an ID, then leave it as is, but otherwise set it to no. And one cool thing that I learned with a student recently is that when you're in a pry session and you've updated something in your code and you don't want to exit and re-enter the pry session, you can type in the word load and then pass in the directory of the file that you want to reload. And then again, we can, let's change this to, oh, I guess it would have just been easier to type this all out, but it's fine. So we're basically creating an instance without an ID, and we're seeing that the ID is nil. So again, whenever we see that the ID is nil for a user, it means that this user has not been saved to a database yet. Are there any questions so far? Okay. So in order to save anything to a database, we need a database first, right? And if I go check out my DB right now, you know, we haven't established anything. We've just established that there's a database, but we haven't given it rows. Is there ever a case where we would want to manually pass an ID to initialize? Brandon, I would say the answer is no, because we are going, although we're not going to set up all of the restrictions to make it difficult to manually set up an ID, we're just going to basically following a principle on our own terms that we should never assign IDs ourselves. We should always just get IDs from the database. Now, I think that there's an example that I want to make where I can show you just how powerful and important the unique attribute ID is, the unique primary ID is. Could you ever set up initialize to assign unique IDs like SQL does? Yeah, you could basically have a class variable that's a counter, for example. Of course, this is something that we would have maybe asked you to experiment with in your previous project, but now that SQL is supposed to be handling the primary key integers for you, this is not something that you should do. But I think what Lucy is trying to say is we could have set like ID count, right? Or ID equals, 1, and then in the initialize, we would assign the current ID to this instance of a user and then increment it so that the next user that gets created would have an ID of 2, etc., etc. Is that what you were asking? I think that, let me see if I read the question correctly. Yeah, okay. Yeah, so just something like that. Okay, so again, we haven't set up anything. Our database, if we were opened it into DB browser right now, would show us nothing, right? All we've done was told SQL that this is where the database is, but that's all. So I think it's up to the class user to tell the database how it should be set up. So I'm gonna go ahead and I'm gonna create a class method called setupTable. And this is gonna be a method that's gonna say, that we're gonna run at the beginning of our application to say, set up the table to be able to handle users, but we of course don't want the database to try to attempt to set up a table if we accidentally call this method more than once. So we can actually use this method called create table if not exists. This is like a SQL code, command in SQL. And let's set up this table. So who wants to give it a shot? How would we set this table up? What's SQL code? And you can kind of just imagine that if not exists is not there. It would be the same way. Create table if not exists. Anyone remember the SQL code to set up a table? So we're gonna create table if not exists, and we're gonna say users. Remember, it's plural. Yep, cool. So the way that Brandon wrote it is if we were inserting a row into the table. But right now we're just we're setting up the table, right? So the first thing that we're gonna have again is the ID. That's exactly what we want, the ID, right? And it's gonna be an integer primary key. Thanks, Lucy. The second thing that we're gonna have, and let me make this smaller so that we have more room here. And then I guess I can turn on soft wrap just in case. Primary key, and then we have name as text. Yep, and then email as text. Perfect. Awesome. So we have access to our database, our global variable here, right? I'm just going to call execute. I'm going to pass that SQL in. So I'm going to use my handy load user RP file again. Oh, did I say integer E? Why do I always do that? I want to say primary and integer in the same line. Okie dokie. And now I'm going to say user dot setup table. Cool. That looks like it worked. I got an empty array back. Don't know why it does that. But if I were to open DB browser Lite for SQLite, and if I were to open up a database and go check out this database that we created, I should see that we have a table for users, and it's got 3 columns. So nice work. In the future, if we just wanted our environment file to do this for us, I could just also call this here. But because we have it written set up table, if create table if not exists, the function will run and say, yeah, this table exists, so we don't need to create it again, right? Again, it's important to notice the order that we're calling these things in. I guess I could have said, because the user file requires that the database is already created in order to be used. So putting it up here would not work, I believe, because it would be trying to look for a database. I think that's the case. I tried doing this yesterday. I just noticed that the order of how these require relatives was important. And then once we have set up the database, we can call the user file, and then we need the user file here in order to call the user class to set up the table, right? Okay, awesome. Any questions? Where does it save to the DB? Great, Nelson. Here we go. This is exactly the next point. As we've noticed, I have Jen and I have Chris. These are instances, right? But if I were to execute the code that says select all from users, I would get nothing. I have no users in my database. How do we get the users that we've created? Well, yes, kind of. Lucy asks, in initialize, could you do insert into user values and then iterate over the attribute hash to get the rows with other user objects? Yes, but whenever we make something, we never want to save it right away. So as Nathalbert has mentioned, we want to create a save method, right? It's actually good that I've created this and I haven't persisted it to the database yet, because what if I actually want to change my email, for example? There are many Chris's at Flatiron School, so we have to specify my last name, right? Oops. Oh yeah, I forgot that we created Chris before we did the ID of no. Let's do that. So I want to create a method called save. And this method is going to be responsible for putting this information into the database. So, does anyone want to give a stab at how we would do this? Yeah. So we can create SQL code that says insert into users, right? Our name and our email, right? And then we set the values equal to question marks at this point. And I'll show you why in the next line of code. When we say db execute, and we put in our SQL, we put the arguments here. So the name is going to be self.name, and the execute is going to be self, and the email is going to be self.email. Awesome. Now, the one last kind of tricky bit of code that I think you just kind of have to memorize, and I might have to look this up, is once we've saved a user instance to a database, it now has an ID. SQL has given it an ID, and we want to take that ID that was created and set it equal to, oh, actually just thought of a different way we could do it. And now I want to assign it to the instance that we're playing with, right? So I know that db execute is going to return an array, I believe, of the object that we just created. So the return, so the new row, again, is actually going to be an array. And I know that new row, there's only going to be one element in that array. And I'll show you this later. I just know this right now. The new row is an array, but there's only one element in the array. And that element is the hash of the key value pairs of the thing that we just created. And we know that there is a key of ID. Okay, I'm just gonna try this. So we'll say insert into user. Let's see. So db.execute. How should I do this? I'm going to use I guess I'll just do it really quick. db.execute insert into users name, email, values, Chris m@flatironschool.com. Oops, forgot to put a quote here. What did I do? Oh yeah, single quotes. What did I do? Oh, no comma after this here. Okay, cool. So that doesn't return what I was looking for. I thought it would return something. Okay, this is good. This is good that I tested this. Yeah, Nethelbert is right. So Nethelbert gave me this code, which is exactly what I was looking for. This code basically just says, go to the very last thing that we put in. Again, it's going to return an array, right? And then that array is going to be another array of the values in the columns. And therefore, the first value in that column is going to be the unique primary key ID. So this is the ID that we received from DB. And then we'll say self.id now equals the ID received from DB. And now now our instance should have an ID. So we're going to practice this with Jen's instance, the instance that we made of Jen. So let me go back to my load user. Oops. Oh, I forgot to close this. No, I didn't. It's very close, but maybe not. Select last row. Select last insert row from users. Last insert row ID. Last insert row ID from users. Hold on a second. I have to find this. It's very close. It's something like this. Select last insert row ID from. Why isn't that working? DB execute select last insert row ID from users. From tweets. Oh, yeah. You're right. Okay. But still, why was I getting this error? Syntax error. Expected. Oh. No, that doesn't make sense either. Okay, let me just go back and try this again. So, tweets, users, ORM. And sorry, y'all, bear with me for just a second. So, why doesn't this want to work? So save this. That works. Why does that? Here's the code that I literally wrote yesterday. That should work. Huh. What is the difference? I literally don't know what the difference is. Huh. Okay. Sometimes it's just a weird small thing that I can't notice right now. Okay, so now we have Jen, right? Oh, I deleted Jen. We have to start over. Maybe it was the parentheses. So if we look here, db.execute last from user ID brings me back this, right? It's an array of a hash. And then if we do this, we get to the hash inside of the array. And then I'm imagining that this also just means the first value in the key value pair. So I just went ahead and added the parentheses or the brackets with zeros at the end to show you the difference. Okay, we're running a little bit out of time.
Did Chris accidentally leave?
I think so.
Chris' network is suck.
I don't think that was on purpose, but it looks
I
like
know.
he may have accidentally hit force quit on his.
I thought I lagged out.
Oh man, then it's one way to exit a lecture. I think that was I don't know what other parts he was going to add in, except for maybe, yeah, he's gone. Shoot. Except for maybe like a method to grab all the users or something like that. Do you guys, in our last 5 minutes, because I probably don't have time to figure out where his code is and get it up. Do you guys have any last questions? Oh, I also realized I stopped video sharing. Sorry. Okay, Lucy's got a question. If we had an object with like 100 attributes and we didn't want to write them all out, is there a way to iterate over all the attributes and add each of them to its own individual column?
Like, what I mean is, like, instead of just email and name, what if we had like email name and like a ton of other things for each object? And is there like a method we can use to like iterate through and be like, okay, the name goes here, then and then new, I don't know.
So one of the labs that you'll get to, and I don't, yeah, copy paste. I don't think that you guys are there yet, is a lab where you basically set up a class that every model inherits from. And that class is set up to be super flexible. So like whatever attributes get sent in, it is able to handle. However, in general, I'm trying to think about every time I've used a database. You do always have to send it in with key value pairs, like always. But way down
I thought
the
I
line,
remembered
go
there
ahead,
was a lesson on like meta coding, I think it was, that Avi did, and I think that went over how to add in key value pairs into a class.
Yeah, so that's kind of what Chris was using the send method for in initialize, was the meta programming. So he didn't write it out in the initialize method, he just used send. However, if you think about it, like either when we're initializing the object or when we're updating the object, at some point we can handle it in a way that like we write one line of code and it's flexible for every attribute. But at some point, we're going to have to say this value that I'm sending in is an email value. And so no matter what, you would have to tell it what it associates with. When you get to form submission, when people submit forms, the information is going to come in a hash with keys pointing to values. So you wouldn't necessarily have to like rewrite it every time. Like it would already be in a pretty hash that you could then send to your send method or to an update method or to something like that.
So if you had just like a hash, so like I guess my question is like, because I feel like if you had a hash with all the key value pairs, then you could just iterate over it and put it inside the database using the send method. I guess where I get stuck is like, well, how do I get all of the attributes of the object into a hash? Like, because here in the save method, it's like it's an instance method, right? So you have to be like, take this instance and put all of its attributes in the form of key value pairs and then put it in the database. And that's like sort of where I get stuck. I'm like, I don't know how to do that, or if you even can do that.
So at the end of the day, at some point, there will have to be some work in writing the attributes. It could be that the user feels that you spend all of your work setting up a form that has lots of attributes. And then from that point, you can handle it as a hash and don't have to deal with them individually.
Yeah.
Or like, honestly, no matter what, at some point you would have to write out the attributes, unless you were to have written them out in an Excel document and imported the Excel document.
Right.
And, you know, so it's like, but even then it's like, well, someone had to write it in the Excel document. So somewhere, or maybe you're scraping them. That actually could be the one chance you wouldn't, is if you were to like be scraping all of the information and getting your attributes that way. But there are lots of shortcuts. It's just probably at some point you will have to write it out.
Right, sure.
Yeah.
Yeah, I think that makes sense.
Yeah. Good question. Anything else? We're going to come back to this tomorrow, and I think it'll be a better testament of what questions you have, because you'll have a chance to actually be doing the work with us there to answer questions. And so we'll build the other half of this tomorrow. Cool. Well, thank you guys for being here. And as always, reach out to Chris or I over Slack if you run into questions in the meantime. Bye, everyone.